Hello everyone, welcome to this new session on switching theory and logic design. Myself Dr. Sohail Rana, and today we are going to begin a new chapter, that is Boolean algebra. This is our 19th session. So first let us see few basics introduction about the Boolean algebra. So switching circuits are also called as logic circuits, gate circuits, and digital circuits. So what are the parallel names? Say we can call it as logic circuits, right? Or switching circuits, they on and off, or they use the gates, so we can say gate circuits. As they make a digital circuit, we call them as digital circuits, right? So there are different names. So similarly, switching algebra, switching logic, there is a pattern of zeros, ones, and there are different pulses, right? So all of them, when we are performing some algebraic operation, they are called as, say, some switching algebra, the algebra related to switching, or it is also called as Boolean algebra, right? So hence switching expressions and Boolean expressions mean the same. Boolean algebra is a system of mathematical logic. We can say we are using different mathematical logic. It is an algebraic system consisting of the set of elements. So these sets may be 0 or 1 only. Two binary operations. And basically we use, say, OR gate and AND gate, and one NOT gate as the basic gates. Basic gates are, say, AND, OR, and one single input, single output NOT gate, right? So it is the basic mathematical tool in the analysis and synthesis of the statement can be expressed by Boolean function. And Boolean algebra is governed by certain rules and laws. There will be various rules and laws we have to study about the Boolean algebra. So we will use capital letters to represent the variables. So we will use, say, capital letters to use variables. Okay, any single variable or a function of the variable can have a value either 0 or 1. Okay, so these binary digits 0 and 1 are used to represent the two voltage levels. One voltage level is around plus 5 volt, that is for 1, and another voltage level is around 0 volt for logic 0. So actually in practice we don't get exact these values, but we get some value. Suppose 2 voltage, about 2 voltage. So we'll treat it as, say, 1, logic 1. Fine, and something which is less than 0.8 volt, we'll consider it as logic 0. So one can be considered as true logic or on logic or high logic. All of them have same meaning. 0 can be considered as false logic, off logic, or low logic. Okay, now this Boolean algebra differs from the ordinary algebra and the binary number system. Okay, in Boolean algebra we cannot say A plus A is equal to A and A dot A is equal to A, because the variable A has only a logical value. It doesn't have any numerical significance. In ordinary algebra, when we say a plus a, that becomes 2a. That doesn't happen in the Boolean algebra. There is one difference. Now a dot a, in normal algebra, it becomes a square. It doesn't happen here because the variable a has a numerical value here. The Boolean algebra 1 plus 1 equal to 1. Okay, whereas in binary 1 plus 1 is equal to 10. That is, we get 1 plus 1, 0 and carry 1. But here in Boolean algebra 1 plus 1 equal to 1. And in ordinary algebra 1 plus 1 is equal to 2. So these are not applicable in Boolean algebra. And there is nothing like subtraction or division in Boolean algebra. So in Boolean algebra, no division or there is no multiplication, right? So there is no division and multiplication like we have in our normal mathematics, right? So these are not available. So then in Boolean algebra, multiplication and addition of the variables and functions are also only logical. The actual representation of logic operation and the logic multiplication is the same as the AND operation, and the logic addition is the same as OR operation. So AND represents multiplication, OR represents addition, right? So there are only two constants, 0 and 1 are the two constants. And whereas in ordinary algebra, we can have any number of constants. And when it comes to variable or functions of variables, in Boolean algebra, we can assume only two values, 0 or 1 for constants. And we can, for variables, we can use any number of values. So in Boolean algebra, if a is equal to 1, then a is not equal to 0. And if we say a is equal to 0, then a cannot be equal to 1, right? So these are some basics about Boolean algebra. Now, what are the logical operations what we require in Boolean algebra? Once we will list out. So first, three basic operations we require. And okay, so AND operation is similar to multiplication in ordinary algebra. So it is logical multiplication, and it is represented by some intersection symbol like product for dot, or a symbol of intersection like this or like this. So this is like intersection. So we have to remember these three we can use for representing the AND gate operation. Then say we have next one is say OR gate, OR operation. Now this is OR operation is similar to the addition operation, and this is logical addition performed by OR gate. Now it is represented by say some plus sign or this V or U sign, which represents union. It is called as union. Okay, so this is about OR gate. And third basic gate is NOT gate. So NOT operation in Boolean algebra is nothing but complementation or inversion. If input is 0, output will be 1. If input is 1, output will be 0, right? So the NOT operation is indicated by a bar over the variable or any prime number, right? So if we want to go for the hierarchy among the operations, then parenthesis first, parenthesis first, then and then first and then parenthesis first, then and then OR gate. This is the flow, the preferences. Then next, NAND operation. We require NAND operation. Okay, NAND operation. For NAND operation, this is nothing but AND operation plus NOT operation. That is, it is the negation of the AND gate as performed by the NAND gate. Negation of AND gate. The next one we require is NOR operation. NOR operation is NOR operation is equal to OR plus NOT, right? So it is the negation of the OR operation as performed by the NOR gate. Fine. So apart from that, we have two other gates. First one is XOR and another one is XNOR. XOR and XNOR operations on variable A and B in Boolean algebra are denoted by, say, A XOR B or A XNOR B. This is equal to A B bar plus A bar B. This is equal to AB plus A bar B bar. So again we will discuss them. XOR operation is also called as modulo 2 addition. Okay, so XOR is also called as modulo addition. Okay, so now let us see few axioms and the laws of Boolean algebra. Now let us see few axioms and laws of Boolean algebra. So axioms or postulates, these are also called as postulates of Boolean algebra are a set of logical expressions that we accept without proof and upon which we can build a set of useful theorems. So these axioms are nothing more than the definitions of three basic logic operations that we have already discussed. What are three logic operations? We have AND, OR, and NOT gate, right? So each axiom can be interpreted as the outcome of an operation performed by a logical gate. Now these three we will segregate. Say first we will see for AND operation. So for AND operation, say axiom 1. Axiom 1 is that if both inputs are 0, output is 0. Then axiom 2 is if first input is 0, second input is 1, output will be again 0. Axiom 3 is nothing but if first input is 1, second input is 0, its output will also be 0. Axiom 4 is nothing but if both the inputs are 1, their output will be 1. Similarly, we can have axioms for OR gate. For OR gate, we will list out the axioms. Say axiom 1 we will take. Say axiom 1. Say if both inputs are 0, 0 plus 0 will be 0. Then second axiom is if first one is 0, second one is 1, output will be 1. Third axiom is if first one is 1, second one is 0, output is 1. Fourth axiom is that if both of them are 1, answer will be 1. Then third one, say for NOT gate. The third one is for NOT gate. NOT gate is a very simple gate. There are two axioms. Here we can give numbers like this is 4. So it will be 5, 6, 7, 8. So here we will get axiom 9. Axiom 9 is 1 bar is equal to 0. Axiom 10 is 0 bar is equal to 1. Now these are axioms. Now let us see the laws. So there are different laws. Let us see the first one, the first law. The first one is the complementation laws. First one is complementation laws, right? So the word complement, what is meaning? Simple meaning of complement is to invert. Complement meaning is to invert. What is meaning of invert? Invert means making 0 to 1 and 1 to 0. Fine. So there are 5 laws of complementation. They are like given as say law 1. Let us see law 1. Law 1 is zero bar is equal to 1. Law 2 is 1 bar is equal to 0. Law 3 is if A is equal to 0, then A bar is equal to 1. Then law 4 is if A is equal to 1, then A bar is equal to 0. Then law 5, if we have A double bar, that is nothing but same A. It is double complementation law. That is called as double complementation law, right? Double complementation does not change the function, right? Okay, these are complementation law. The next one we have AND laws. Second one is true. We have AND laws. Okay, there are 4 AND laws. Say law 1, if we take A dot 0, means anything multiplied by 0 will be 0. This is called as null law. Then second law is A dot 1 will be A. So if A is 1, it will be 1. If A is 0, it will be 0. This is identity law. This is identity law. Then third law. Third law If A dot A is there, that is equal to A only. Suppose A is 0, B is 0, it will be 0. If A is 1, B is 1, it will be 1. If we take A dot A bar, it will be 0. These are 4 AND laws. So few more laws and other details we will see in the next session. Till then, have a good day. Thank you.